Let's take a question, guys. Uh, let x1, x2, x3 are some solutions of this equation log x square minus 4 equals to log of 4x square minus 6. Okay, where the base is 4x square minus 6. Here the base is x square plus x. Then find the value of summation of xi square, guys. Okay, so let's see what is the meaning of this, guys. What's the meaning of this question? Let's try to understand this. So let's try to find out the meaning of first of all the meaning of this summation of xi square. The summation of xi square is what, guys? The summation of xi square is the sum of squares of the roots, guys. So it means this x1 square, x2 square, x3 square, x4, whatever are the number of roots that we can find out, we have to find the sum of squares of those values. Okay, so this is the meaning of this. Now how do we approach this, guys? The approach of this is, as you can see here x square minus 4, these in this equation the argument is same. So if I make the argument x square minus 4 as 1, means both sides, if I make x square minus 4 1 here also, then it will become 0 and it will satisfy irrespective of any base value. So this is the first hint of this, first way to approach this. And what else we can do apart from this? The second possibility of the equation being equal is, see, a is here x square minus 4 only. A is x square minus 4. So I have written a here. Okay. Now the bases are different. Here the base is b, here the base is c. Base is x cube plus x. Here the base is 4x square minus 6. Okay. So the base is here x cube plus x. This is 4x square minus 6. So this two can be equal. Log a base b is equal to log a base c if what? If b is equal to c, guys. If we equate the bases, arguments are already same. So if you equate x cube plus x is equal to 4x square minus 6, we can again get the equality satisfied. So these two ways, these two are the possibilities, first or second. So whatever the roots that we get from first or second, we will that many roots would be the total roots of the given equation. Okay, so we will start with the first one. First case, when log 1 equals to log 1, means x square minus 4, in this equation x square minus 4 is taken to be 1. So x square becomes 5, which gives x as plus minus root 5, guys. Now the thing is, we know about the domain constraint that the base should be positive. Okay, so x cube plus x, this is the base, this is another base. These two bases should be positive, whatever the value of x that we are obtaining. Okay, so x square minus 4 is 1, so this is already satisfied. Okay, this is already satisfied. So x cube plus x greater than 0, 4x square minus 6 greater than 0, we must test for x equals to root 5 and minus root 5. So if you substitute x equals to root 5 minus root 5 in x cube plus x, okay guys, in that case what will happen? It becomes negative, minus root 5 whole cube minus root 5 is negative. So x equals to minus root 5. We won't take it as a root, so this value is discarded. Similarly, if you take x equals to plus root 5 and you substitute it in x cube plus x, so since this is positive, x cube plus x would be root 5 whole cube plus root 5, which is a positive number. Similarly, if you substitute x equals to root 5 in 4x square minus 6, it will give you 4 into x square is root 5 square, which is 5 minus 6, 20 minus 6, which is 14. Again it is positive. So x equals to root 5 is making the base positive. So this we will take it as a root and we will give it as name as x1. Okay guys. Now so that we will do. Now the second way is when b is equal to c, when the bases are same. A is fixed, as we discussed, a is x square minus 4. So we need to equate the bases so that log a base b becomes log, since c is also equal to b, so log a base b equals to log a base b, the equality would be satisfied. So b is equal to c we will do. So here what we will do, we will equate these two like this. And now since this is a cubic polynomial, we have to think of its roots. So guys, the constant term, the factors of the constant terms, which are plus minus 1, plus minus 2, plus minus 3, plus minus 6, that we need to put, because cubic polynomial roots are obtained by hit and trial mostly, okay, always rather, if at all they have rational or integral roots. So x equals to minus 1 is the simplest one, x equals to 1 is also there. So x equals to minus 1, if you substitute, it will satisfy the root, the equation like this, x equals to minus 1. Okay, but if you substitute, so it will make minus 2 equals to minus 2 both sides. But since the bases cannot be negative, these two are although equal, but the bases are negative. So minus 1 although is a root of this cubic, but we will discard this. Okay. Similarly, 1 also you can use using hit and trial, it won't satisfy. So after minus 1, 1 won't be satisfying. So we will substitute 2 plus minus 2 plus minus 3 and so on. So now is the turn. Let's substitute x equals to 2. Minus 2 also we can substitute, but we will find out that minus 2 won't satisfy. So if you substitute x equals to 2 here, it will make both the sides equal to 10, which is positive. But the problem with x equals to 2 is it will make x square minus 4, which is the argument, 0. So 2 although is a root, guys, 2 won't be a root of the equation. So 2 although is what, guys? 2 although is a root of the cubic, but it won't be considered to be a root of the logarithmic equation. Why? Because it is making the argument, which is x square minus 4, 0. Now in using hit and trial in the similar way, if we substitute 3 minus 3, you will see x equals to 3 will not only satisfy and make the basis positive, but at the same time it will make the argument, that is x square minus 4, it will make the argument positive as well. So x equals to 3 is not only a root of this cubic, but it's also a root of what? It's a root of the logarithmic equation. So 3 is satisfying all the constraints, domain constraints of the logarithmic equation. Minus 1, 2 being root of the quadratic. Minus 1, 2 won't be considered, 3 is a root. So from case 1, guys, what we got, guys? from case 1 we got the root x equals to plus root 5. From case 2 we named it at x1. Case 2 we will got root as 3. Let's say it is 2. So 2 roots only we got. Okay. So the solutions xi square is nothing but the sum of the squares of these two. Root 5 square plus 3 square, which is 5 plus 9, 14 is the answer, guys. Let's try these examples, guys. We have to find number of solutions of this equation. Log, the base is x square plus 6x plus 8. Inside the argument is also a log whose argument is x square minus 2x, and base is 2x square plus 2x plus 3 and equal to 0. That is the log equation. We have to find number of solutions. Okay, so clearly what the meaning of this is, what, let's say if there are two solutions, namely x1 x2, so our answer should be 2. So we have to find number of solutions instead of the solutions. Now the thing is how we can solve this, guys. Now this is of the form log, some base is given and inside is some another log whose some base is something else and argument is something else equals to 0. This is of that kind. So this is the argument and this is the base. So using log m base n equals to k, we can use m will come out and it will push k. So in the similar way, the outer base a will come out and it will push 0, so it becomes 1. And again now we will solve this log equation. So that way we can proceed by using what the concept would be to use the definition log m base n equals to k is m is equal to n to the power k. So after getting x, what next we need to do? After getting x, we have to put it in the question because we need to satisfy, we need to ensure that it is satisfying the domain. So we have to take care of the domain constraints. Okay, so we will solve it first. So as usual, the inside I haven't written. Inside is again some log. Okay, the outer log is this whose base is this. So x square plus 6x plus 8 will go out, it will push 0. So what we are using is log m base n equals to a, m is equal to n to the power a. Now this becomes 1. Now this outer log was, inside log was this log x square minus 2x, base was 2x square plus 2x plus 3, so equals to 1. Again we will use the same log m base n equals to a, m equals to n to the power n a, the definition. So this x square plus 2x plus 3 will come out and it will push 1. Okay, so it becomes 2x square plus 2x plus 3 to the power 1. The left hand side will be free of log, it becomes x square plus 2x to the power 1 means this only x, and LHS is same. So x square we will take on right hand side, 2x also we will take on the right hand side. So it becomes x square after becomes what? It becomes minus 2x square plus minus 2x will becomes plus 2x, and then if we solve this, this becomes x square, 2x plus 2x becomes 4x plus 3 as it is. The roots can be formed by of this quadratic. We can use splitting the middle term, 4x as 3x plus x and then x square plus 3 and x plus 3. Here you will take x common, so we will get x plus 3. X plus 3 is as it is, so x plus 3 comes out, x plus 1 we are left with another root. So we got x plus 3 equals to 0, x plus 1 equals to 0. So we got x equals to minus 3 and x equals to minus 1 as two roots. Now the thing is we need to ensure the domain. So we will substitute each of them one by one. So starting in this equation, okay. So x equals to minus 3 and minus 1, we will substitute one by one in the given equation, original equation. So x equals to minus 3 we will substitute. So x equals to minus 3, if we substitute, if we check the base here, if you substitute minus 3, we will substitute minus 3 everywhere, here also, here also, here also. Now if you check here, this particular base, outside base of the outer log, it will give us minus 3 square 9 minus 18. It becomes what, guys? It becomes 9 plus 8, 17. 17 minus 18 becomes minus 1, which is negative. The base cannot be negative, so outright we will discard minus 3. We won't calculate the other values, 2x square plus 2x plus 3x square minus 2. This we won't substitute because this itself, the first one got negative, so we will outright reject this minus 3 root. So minus 1, now minus 1 we will substitute in again in this given equation. So minus 1 substituting everywhere. Okay, so minus 1 plus 6 plus 8, minus 1 whole square plus 2, 2 into minus 1 square minus 2 plus 3. This this will the outer base will give us 3, the inner base will give us 3, and this will also inner argument will give us 3. So log 3 base 3, guys, is 1. Outer, so log 1 base 3 is 0, 0 equals to 0 is satisfying, and domain constraints are also met. So x equals to minus 1, guys, x equals to minus 1 is the only root. So number of roots, as you can see here, the question is asking us the number of roots. So answer is only one root, and that is 1. So answer is 1. Okay, one root only. Okay, so we did by the definition. So guys, the next property is if log m base a plus log n base a, if they are added, what it will be. So previously, as I said, they used to take log common, and it was the wrong notion that was prevalent in the past when the log was evolving. But is this equal? So clearly it's not. So what's this log m plus log n equals to? So guys, log n plus log n is log a base m into n, guys. Okay, how we can prove this? So we will assume log m base n to be equal to what? We will assume log m base a to be x in this proof. So using the definition, m becomes what? A to the power x. Let's say this is 1. In the similar fashion, we will assume log n base a to be equal to y. So y n equals to a to the power y, guys. This is second. So what we will do, we will multiply first and the second. So if we multiply first and the second, what will happen? M n, these two if we multiply, so m and n gets multiplied, and a to the power x multiplies to a to the power y. So you will get this, which is mn equals to a to the power x into a to the power y. Using the property of exponent, it becomes what? Yes, it becomes a to the power x plus y. Now taking the converting it this to logarithmic form, so we can write this as log mn base a as x plus y. Now x plus y we know from first it is log m, and from second it is log n, and that's how it is proved, guys. So for example, log 7 plus log 8, if I ask, so log 7 into 8 it becomes, so the answer is log 56, guys. Okay, in the similar way, anything if I write like log x square plus log 3 by x, so this is this is equal to what? Log x square plus log 3 by x, base is same. This is valid when the base is same. Okay, the proof is valid when the base is same. This is equal to what? So what we can do here, so 3x square is multiplied by 3 by x gets cancelled. So log 3x base 2 is the answer. That's how we use it. Now what is the generalization of this? Generalization is generalization of log m1 log m2 base is same here, which is a log m3 and so on till log mn. Okay, so the generalization in the similar way, if we prove, if you take these two, apply the property, you will get log m1 m2. Now you apply this and this, you will get log m1 m2 m3. So in the similar fashion, it can be proved that if we add logarithms of m1 m2 m3 and so on, guys, it would be log m1 m2 m3 all in multiplication till mn, or till whatever number of terms it is. So for example, here if you see, if we have to find log 2 plus log 7 by 2 plus log 1 by 7 is equal to what, guys? So we will use this. So these two arguments will come in multiplication. Base is as usual, it is 2. So 2 cancels with 2, 7 cancels with cancel, we will get log 1. Okay, we will get log 1. And base is what, guys? Base is 2. So log 1 base 2 is 0, guys. So it is 0. Now for example, let's take an example. X y square z is 140. We have to find the value of log x plus log y square plus log z. The base of all these three logarithms are 140. So what is the value of this? So using the rule, that's the way, that's a hint. The solution, this is taking log both sides and solve. So taking log both sides, we will solve. So taking log both sides. Now what is the base that we need to use? Base we have taken 140. Why? Because here the number is 140. That's why we have taken base as 140, so that we know that log a base a is 1. So in the next step, this becomes 1. So that is the answer, guys. Okay. Now let's take another example. Log 2 plus log 3 plus log 4 till log 220 27 is log x factorial. So what is x? Find x. So again we will use what? The solution, we will use log. So in the solution it will be like this. Log all will come in multiplication. Now 2, 3, 4 till 2027, 1 we can write just like that. Multiplying 1 won't affect. 1, 2, 3, 4 till 2027 is 2027 factorial. So if you compare this x and this, your value of x would be what? Yes, it is 2027, guys. Now the next rule is, guys, log m minus log n is equal to what? So can we say that this is equal to log m? We can take log m minus n common. Is this correct? So as discussed previously, it was misused by mathematicians at those times, but this isn't correct. So what's the correct one, guys? So log m minus log n, guys, the rule is log m upon n. What about the base? I haven't written the base here. So like if here base is a and here also if the base is a, so bases are same, then only this formula is applicable. Okay. So how it came? So what is the proof, or what is the hint of the proof? So guys, we have seen the hint of this proof. It is similar to log m plus log n is equal to log mn. The same way we can do this also. What we need to do is we assume is log m as x and y and so on, converted it to exponent form, multiplying or dividing them and so on. Okay, that way it can be proved. Let's see some examples, guys. Like log root 7 minus log 3. So we can write it as log root 7 by 3. As simple as that. And log 11 minus log 121. So log 11. So the base, if let's say here if it is 5, here it is 5, then here also it will be 5. Let's say if the base is 10 here, so the answer will also be in base 10. Now 121, if I ask you what is 121, 121 is basically 11 square. 11 cancels out, it is log 1 by 11 base 10. Take another example. Log 3 base 1 minus x minus log 2 base 1 minus x is half. We have to find the value of minus 4x. So again, what we will do, guys? So yes, we will use log m by n. So this becomes log 3 by 2 base 1 minus x is equal to, right hand side is as it is, using converting it to exponent form, 1 minus x will come and push 1 by 2 in the power. So we are left with 3 by 2 in the left hand side. Now in order to find x, minus 4x, we will square it. When you square it, 3 by 2 whole square, and this 2 and 2 cancels out, so we will get 1 minus x as 9 by 4. And 1 minus x has to be positive because it is in the base, so it will satisfy the domain constraint. So 1 minus x is correct, 9 by 4 it has to be positive, so no problem. So whatever the x that we will get after solving it, which is 1 minus 9 by 4, which is minus 5 by 4, minus 4x would be correct, and that would be the answer. Taking another example, log 2 cube by 3 square plus log 5 square minus by 2 to the power 6 minus log 2 cube by 7 into 3 square equals to log 5 to the power a, 7 to the power b, 2 to the power c. So find the value of a plus b plus c. How we can approach this, guys? So obviously we need to solve the LHS, and when we solve it, it will come in the form of the powers of 5, 7 and 2. So how many ways we can approach this problem? So as you can see, let's say this is the first term, this is second term, and let's say this is the third term. So three way we can approach. We can use two formulas. One formula we already have seen. Another formula, which is log m plus log n, is log mn. That is also to be used in this question, apart from log m minus log n, which we derived just now. So first approach is we will use log m plus log n in these two, or in second approach we will use log m minus log n in second and third, and then in first, and whatever we get we will use log m plus log n. Similarly, third approach would be first and 3 if we use log m minus log n, and then whatever we get in terms of log we use log m plus log n. So we can use any of the approach which are quite similar and easy also. Approach 2 we will use. So approach 2, rewriting the question and then applying second and third, log m minus log n. So 5 by 2, 5 square, 2 to the power 6 upon will come 2q upon 2, 7 3 square. So 7 3 square, guys, 7 3 square will go in the numerator like this, and 2 6 3 2 cube 5 square is as it is. Now we will use log m plus log n, which is log m into log n. Okay, so multiplying, so this 5 square as it is 2 cube cancels with this, 3 square cancels, gets cancelled, so we are left with 5 square, and into 7 by 2 to the power 6. Comparing it with what is asked in the question, a is 2b 1c 6, adding 2 1 and 6, the answer that will obtain would be what, guys? So the answer would be 9, guys. Okay. So let's see this rule, another rule, guys. Log m to the power n. So the argument is m to the power n here. So obviously m to the power n, since it is written in front of log, m to the power n has to be positive. It states that the power it comes down in multiplication to log m base a, guys. Okay, so m is also positive. Obviously, since it is base, it has to be positive and not equal to 1. Okay, let's see the proof of this. Let's assume y is equal to n log m base a. Let's say this is first. So dividing by n, here in the right hand side we are left with log m base a. Now using the definition, a will come out, converting this logarithmic form to exponential form, this a will come out and it will push y to the power n above like this. So a to the power y by n is equal to m. Now raising by power n both sides, this n and this n cancels out, so we will get a to the power y is equal to m to the power n. Okay, so we are considering these three as numbers like m to the power n, a and y. We are again converting this to logarithmic form. Y becomes what, guys? Y becomes log m to the power n base a. This is second. So from first and second, first we got this, second we got this, so that way it is proved, guys. Taking an example, if any number is in multiplication to a log, then that number goes to the power of the argument. Okay, m to the power n rule also we can say that. So 2 cube, which is log 8 base 5, base remains unchanged. Another one is minus half log 7 base 3. In terms of log, how we will write? So as you can see, again using the same, minus half will go in the power of 7. So it becomes 7 to the power minus half, which can be written like this, which is 1 by root 7 base 3. Now taking another example, 2 log 5 plus 3 log 2 is equal to log of what? Here considering base as any base, so we are not writing any base here. So what we will do, again we will use the same m log n in these two terms, this also. So 2 will go in the power of 5 and 3 will go in the power of 2. So it becomes log 5 square plus log 2 cube, which is log 25 plus log 8, and using log m plus log n equals to log m, and this becomes log 25 into 8, which is log 200. Again write 2 in terms of log base 3. So 2 is a number which is a simple number, doesn't have any log, but we have to convert it in terms of log base 3. So we know that we can write it 2 as what? 2 we can write is 2 into 1, and this one is written as log 3 base 3, guys. Now 2 will go in the power of 3, which becomes log 9, so log 9 base 3. So that's how we have converted it in terms of log base 3. In the similar way, if the question is to convert minus 3 in terms of log of base 5, what we need to multiply minus 3 first of all is by 1, and 1 is written as log 5 base 5 because we have to convert it in base 5. Now 3 will move to the power of 5. 5 to the power minus 3 is 1 upon 125. Base 5 is the answer. Now again, in the next example, express 13 minus log 5 base 2 in terms of log base 2. So 13, since they are asking in terms of log base 2, 13 into 1, if we write, 1 would be written as what? Yes, log 2 base 2 in the next step. Now again, 13 will go in the power of 2. Using the property, it becomes 2 to the power 13. And using log m minus log n, 5 will come in the division log 2 of log 2. So it becomes this. Convert, we have to simplify log 1 by 36 base 6. 1 by 36, as you can see, is the argument. So 1 by 36 we can write as 1 by 6 square, which can be written as 1 by 6 to the power minus 2. Now we will use the reverse of that. Log m to the power n is n log m. So minus 2 will come in the multiplication. Log 6 base 6 is 1. So minus 2 is the answer. Similarly, if we want to simplify log 25 into cube root of 5 base 5. So again, what we need to do, in order to simplify it, we will express the argument in terms of powers of 5. So 25 would be written as 5 square. Cube root of 5 is 5, 1 by 3. Base is 5 only. So the powers gets added. 2 plus 1 by 3 is 2 3s are 6 plus 1 7 by 3. 7 by 3 using the property will come down in multiplication. So 7 by 3 log 5 base 5 is 7 by 3 is the simplified answer. Similarly, we have to solve for x. 2x plus log 8 by 7 to the power x base 7 is equal to log 16 base 7. How we can solve, guys? So what should be the hint? So everything is in the base of 7. So we need to convert 2x in terms of base 7. So we can write 2x as 2x log 7 base 7. And one more, yes. So we can write it 2x like this. It will go in the power. So it becomes 7 to the power 2x plus log 8 by 7 to the power x using log m plus log n is log mn. Right hand side as it is. 7 to the power x. 1 is cancelled with 1. So 1 7 to the power x is left in the next step. So using cancelling log both sides using the property, we will get 7 to the power x into 8 is equal to 16, which is 2. So what is x, guys? Yes, using the definition, it is log x base log 2 base 7. That is the answer. Now the next is write this under root of log square minus 2 to the power minus 6 base 5 in terms of log 2 base 5. What should be the hint of this? So guys, let's assume that log minus 2 to the power minus 6 base 5 is t. So what do you think this should be in terms of t? So yes, this would be t square. And outside is under root. So under root of t square is what, guys? So we know that under root of t square is mod of t. So, and one more thing, minus 2 to the power minus 6 and 2 to the power minus 6. What is the relation? Are they equal or unequal? So, minus 2 to the power minus 6 and 2 to the power minus 6, if you see, they are equal because minus 2 to the power minus 6, you can write plus 2 to the power minus 6 into minus 1 to the power minus 6. This can be written as 1 upon minus 1 to the power 6, which is 1. So yes, they are equal. So do we need this thing in our solution? So that's the hint. Let's see guys in the solution part. So again using what we assumed, mod of t square. So mod of t square is mod t. So t was this log minus 2 to the power minus 6 base 5. So can we write this as this? So now in this, why it is question mark? Because minus 2 is in the argument. Is it possible, right, or is it wrong? So guys, this is not right, this is wrong only because argument cannot be negative. So that's why we need to do what? We need to write this minus 2 to the power 6 as plus 2 to the power minus 6. And then minus 6 will come down in multiplication using log m to the power n property. So now log 2 base 5 is refined number minus 6 into log 2 base 5 using mod of AB is mod A into mod B. Mod of minus 6 is 6 and log 2 base 5 as it is 6 log 2 base 5, excuse me guys, 6 log 2 base 5 mod is the answer. You ignore this but horizontal line. Okay. So let's take an example guys. X raised to the power log x base 3 whole square minus 9 by 2 log x base 3 plus 5 equals to 3 into root 3, 3 root 3. So what we have to find? We have to find sum of all real solutions. So whatever the value of x which satisfies this, we have to find the sum of all of those roots. And so guys, what should be the hint to this? How we can approach this problem guys? So as you can see here guys, this question is some kind of following this kind of exponential. So we can solve this since the bases are different. What we can do, we can take log both sides. So that should be our approach. That is the hint. Taking log both sides guys. That's how we will approach this. Now this question arises, what is the base? Question mark is what is the base that we should take? So as you can see here, the question here, the base they have given is 3 only guys. In this question, the base is 3. So and here also it is given in terms of 3 only. So we will take base as what guys? The base should be 3. So we will take log of base 3 both sides guys. So taking log base 3 both sides guys, it will be like this. Log base 3 we have taken, log base 3 here, log base 3 we have taken here. Okay, now let's say log x base 3 is L. Why I am writing it L as? Because every time you have to write log x base 3 which is cumbersome, time taking. So for that it serves only the purpose of writing, to write less. It doesn't serve a purpose of any conceptual purpose or like something like that. So log x base 3, this now becomes guys what? So log x base 3. So log x base 3 is written as L here also and here also it is like this. And 3 we have root 3 we have written 3 to the power half. Okay, since we have taken log base 3, now as you can see here, this from this step to this step, how we got this. Now as you can see here, we from this to this we used what guys? Yes, we use the result log m to the power n is n log m. So this thing which was the power of this thing L square minus 9 by 2 L plus 5, which was in the power, now it came down in multiplication. So we can say that this is, when this was n, now it came in multiplication. So L square minus 9 by 2 L plus 5 came in the multiplication of log x base 3. So here the power, nothing left here as a power, guys, in the power of x. Similarly, 3 into 3 to the power half is written as 3 to the power 3 by 2, which again in the next step, by using the same result, log m to the power n is n log m. This 3 by 2 which was in the power now will come in multiplication of log 3 base 3. Here again log 3 base 3 is, I have written as L. Okay. So now as you can see here, log 3 base 3, log a base a is 1, so log 3 base 3 is 1, we will replace it, and this L gets multiplied to this expression in the bracket. So this L square becomes L cube, 9 by 2 L becomes 9 by 2 L square, plus 5 becomes 5L, and right hand side becomes 3 by 2 because log 3 base 3 is 1. Now if you multiply this 2, cross multiply this 2 on left hand side, which now gets multiplied in the next step, and L square, L cube becomes 2L cube, 9 by 2 L square becomes 2 gets cancelled, so it becomes minus 9 by 9 L square. 5L after getting multiplied, it becomes 5 into 2L, 3 right hand side is as it is. So now this, we are left with this cubic 2L cube minus 9L square plus 10L. This 3 we will take on the left hand side, it becomes minus 3 equals to 0. And what about the roots, guys? So we know, guys, that the roots of a cubic, they can be calculated by hit and trial. So 3 is a constant term here. We can try to factorize it, although the constant term is 3 by 2 here, but we can start with a small value like 1, minus 1, 2, minus 2, and so on. So fortunately, if you start with L equals to 1 and substitute it in this equation, fortunately it will become, it will satisfy it. Minus 7 plus 7 equals to 0. So L equals to 1 is a root, means what, guys? L minus 1 is a factor. L minus 1 is a factor of this polynomial. Okay. So we can rearrange this polynomial in such a way that L minus 1 factor comes out. So what we will do, we will separate 9L square minus 9L square, we will write it as minus 2 minus 7. Similarly, plus 10L we will write as plus 7 plus 3L. Minus 3 as it is, guys. So now as you can see, the first two terms, 2L cube minus 2L square, we will take 2L square common. So we are left with L minus 1. In the last, in the next two terms, from minus 7L square and plus 7L, we will take minus 7L common. So we are again left with L minus 1 as a factor. Similarly, in the second last and the last terms, we will take plus 3 as common. Again we would be left with L minus 1 as a factor. So after L minus 1 gets out, we are left with a quadratic which is 2L square plus 7L plus 3 equals to 0. And so we have one of the root L equals to 1, and other two roots depends on the roots of this quadratic 2L square minus 7L plus 3 equals to 0. Now if you use 3 to the 6 by splitting the middle terms, of 6 minus 1, you can write it, and then the first two terms 2L, if you take common, L minus 3, and from the last two terms also L minus 3 we can take out. So L minus 3 is another root, 2L minus 1 is another root, equals to is another factor. So which leads us to the roots L minus 3 equals to 0, 2L minus 1 equals to 0. So which leads us to the roots L equals to 3 and L equals to half. So finally we got 3 roots of L, which is 1, 3 and half, and L we know that it was log x base 3. We wrote it just so that we can write less. So by using the basic definition from here to here, 3 will come and it will push 1, so it becomes 3 to the power 1. It will push 3, it becomes 3 to the power 3. It will push half, it becomes 3 to the power half. So the two roots, 3 to the power 1, 3 cube and root 3, the sum of these 3 would be 3 plus 27, which is 30 plus root 3, would be our final answer, guys. Okay, so that way we did this question. So we did what, guys? We took log and we used log m to the power n log m, and then we solved the cubic using hit and trial, and that way we solved it and we got the roots.